Okay, in the last video we got cut off by the time limit of my software. We were solving this problem, and we got to the point where we got to 1/2 x is equal to 2. Now what I'm going to do is multiply both sides of this equation by 2, and x is equal to 4. So in all, what we're saying then is that the log of base square root of 3 of 9 is equal to 4, right? Let's take a look at this for a second just to make a little bit more sense to it. We're saying here that the exponent to which we raise the base square root of 3 to get 9 is equal to 4. Yeah? Well, let's check this. Is this true? Well, if I want to take the square root of 3 to the 4th power, that's the square root of 3, times the square root of 3 times the square root of 3 times the square root of 3, I know that the rules for radicals say, oh, I can multiply everything underneath one radical. 3 times 3 times 3 times 3 is 81. And what's the square root of 81? It is 9. So notice that actually does work. Okay, now we're going to use our property, I'm sorry, not our properties, we're going to use the definition of logarithms, changing logarithms to exponentials and back to solve each one of these equations. All right. The first one, we're going to take log base 5 of x equals 3. So we're looking for, if we know that the exponent to which we raise 5 to is 3 to get x, then we just rewrite it that way. We take the base, remember the log is the exponent, so that's 3 equals x. And what's 5 cubed? Oh, 125. All right, great. Let's do another problem. We're going to take the log. This time our base will be the variable. And we're asking ourselves, what base do we raise 3 to get 1/8? Right? Oh, well, what's the cube root of 1/8? 1/2. Great. So x is 1/2. Let's look at this next equation. 8 times 10 to the 2x minus 7 is equal to 3. In order to do this problem, we have to isolate the base first. Okay, so I'm going to divide both sides by 8 and get 10 to the 2x minus 7 is equal to 3/8. All right, now remember, we know that if we take a to the y equals x, that's the same thing as saying y is equal to log base a of x. So here we have the x in our equation, we have an exponential form. We need to put it into logarithmic form, right? So again, the log is the exponent, right? So we're going to say the log, we know it's base 10, of 3/8 is equal to the exponent. Okay, now if we want to isolate the x, we're going to add 7 to both sides. So we're going to say 7 plus log base 10 of 3/8 equals 2x, and then we can divide both sides by 2. Or, and kind of a fancier way to do that is to multiply both sides by 1/2. So if we have 1/2 times 7 plus log base 10 of 3/8 is equal to x. Okay, now this is the exact answer, meaning it's not an approximation, but do you remember how I said that we might be able to, or that we can evaluate logs of base 10 in the calculator, right? Well, let's do that. I'm going to pause this so I can pull up a calculator and then I'll start it again. Okay, we're ready to take a calculator and evaluate this entire expression. The first thing I'm going to do is the log. Oh, look at this. I don't have a log. Well, let me change the type of calculator I have to a scientific calculator. There we go. Now notice I have this key log. Okay, so this log here is log base 10. So I'm going to enter my 3/8, so 3 divided by 8 equals 0.375. Now I'm going to hit the log key. That's going to give me the logarithm of 0.375. I'm going to add 7, that's going to be 6, this whole thing, times 1/2. And since I know that 1/2 is 0.5, I'll put 0.5. Okay, so here I'm getting, whoops, let me get my black thing again. X is approximately equal, and where'd the calculator go? Hold on just one moment. There it is. Let's bring it back in. Is approximately 3.287, and I'll just round it there. I didn't give any directions, but so approximately, come on, baby. 3.287. Okay, that is X. Okay, now what did we just use on the calculator? We just used the log of base 10, right? It is called the common logarithm. It's used so much, and because our number system is base 10, it's on the calculator. Because it's used so much and it's common, usually when you see it, you don't write a base at all. So we understand that the base is 10. Okay? All right. Now let's evaluate some logs in our calculator. Evaluate in the calculator to 3 decimal places. Right? Number 1, log of 3/8. We just did this one, but let's go back and do it one more time. Hold on, I gotta get the calculator back. Okay, so remember what we're doing. We're gonna do, oops, there it went away. Oh, this isn't the easiest thing to do. I gotta put it on top. But we're gonna do log of 3/8. Ready? So let's clear this out. We're gonna go 3 divided by 8. Oops, nope. 3 divided by 8 equals, and then hit the log key. Notice it's negative 0.426 about. So let's put that. So it's approximately negative 0.426. Okay. The second one, let's take 3 log 80 minus log 5 over log 4. Okay. So in order to put this guy in, hold on, I want to, I'm actually going to minimize this window a little, maybe, and try to bring the calculator back at the same time. Let's find the calculator and bring it here. Perfect. Awesome. Okay, so we're going to take, first of all, what we're going to do is take the log of 80. So let's clear this out. 80 log, then we're going to multiply it by 3 times 3 equals. Then I'm going to subtract 5 log equals, and then we'll divide by the log of 4. So 4 log equals. So this is approximately 8.322. Let's see, let's make this a little bigger again. No, maybe not, I'll just move over. 8.322. Alright, one more problem that we want to do in the calculator. ln of 5/3. What? Wait a minute. ln of 5/3? What is that? Well, take a look in our calculator and you'll see it looks like maybe if we do a nope, that's not true. You know what? My calculator doesn't have a natural log. Oops. Okay, we'll come back. We'll find a calculator that does. But let's first define what this whole ln is. All right? What is ln? All right? Well, it turns out that ln is what we call the natural logarithm. And the natural logarithm has base e. So the idea is that if we were to write log base e of x, that's the same thing as ln of x. Okay, and it's used so commonly that it's generally in the calculator. Okay, before though we use the calculator, I've got to find one to evaluate this. Y equals the natural log of x. That is the same thing as saying e to the y is equal to x. So notice again, we say the log is the exponent and the log is the exponent, right? Hold on, I'm going to pause it. Okay, I figured out how to use this calculator. I have to use a shift key, but you may have to on yours, but I bet you just have a button that says ln. So if I want to find the natural log of 5/3, I'm going to take 5 divided by 3 equals, and then I'm going to use my second or my shift, and notice I have this key that says ln. I'm just going to push it. So it's approximately, again to the 3 decimal points, 0.511. Alright? Okay, we'll talk more about the natural log and use it in the next video. You can watch the videos from the book about graphing the log functions, but I just want to give you one more thing to remember about logarithms, about when you're graphing them. Let me expand this guy out. There we go. When you're graphing them. Yeah? So I'm going to graph the exponential function. Okay? A to the x. So f of x equals a to the x. Alright? And I'm just going to kind of do a little rough drawing of it. Here we go. That's this one. Okay? Now, you know that this function has y equals 0 is the horizontal asymptote. You also know that inverse functions are reflections of each other over the line y equals x. Okay, so let's take this function and flip it over the line y equals x. Yeah. So notice this function, by the way, is f of x equals log base a of x. It has the same base. So no longer are we going to have a horizontal asymptote. We're now going to have a vertical asymptote. And it's not going to be the x-axis anymore. It's going to be the y-axis, or x equals 0. Okay? So when you're graphing, this asymptote is going to exist, and it's going to move all around depending on the transformations. You can watch the rest of the videos on the website through the book to kind of learn about shifting it around and where all the important points are.